It's been a few weeks since we did a video, so welcome back to the Ultralight Airplane Workshop. In this video, we're going to add a little bit more to the video that we did back in December on the rudder shape for the UWS-1 Ultralight airplane design that we're working on. I had a much longer hiatus than I had planned on. I planned on having the last 2 weeks of December being a vacation and get back to videos on the 1st of January, which I did get started, but it's been 3 weeks of Murphy's Law interfering with me getting this video done, but I finally got it done. A comment that I got on the first rudder shape video that I did said, I don't think we got to where we expected to go, or something similar to that. And I got to thinking, well, I guess that's true because I really didn't show the final rudder shape. Talked all about the design considerations for the shape, picked out some design parameters, but never really got into the exact shape. In this video, we're going to do that. Here's a sneak peek of what the rudder looks like along with the vertical tail. We're looking at the bottom of it here. So you can see the rudder where this is the hinge line. Here's the trailing edge. This is the elliptical nose that we talked about. And this is the vertical tail. Let me give you a quick summary of what we're going to talk about here. First, we're going to summarize all the design parameters and issues that we came up in part 1 of the rudder shape video. If you have not seen part 1 of the rudder shape video yet, I'll put a link to it up here in the upper right hand corner. Next, we're going to talk about what I changed in OpenVSP on the UWS-1 design to make it a little bit easier to export it out. I had to make a few changes, and then I had to learn a little bit on exporting and importing into a CAD program, and so I'll give you a little bit of clue of what I learned there. There are some pieces of data that don't come out when we do the export from OpenVSP. Basically, those data are where the hinge line is, the coordinates for where the bottom gap is, position where the top gap is, etc. So I'll show how I get those coordinates, and then I show how to put those coordinates into a spreadsheet and do some calculations on them so that I have more useful data to plug into the CAD program. And then the last part, since the video was getting pretty long, I just quickly went through what I did in the CAD program to create the shape from the file I imported from OpenVSP. Here is the only slide that I have in this video. I want to go back and review some of the characteristics that we decided on for the shape of the rudder on the UWS-1 Ultralight. In that video we talked about several different things. Most of it had to do with chords of the rudder, chords on the nose, and also the shape of the nose and shape of the trailing edge. For the chord of the rudder, and in this case I'm talking about that chord being from the hinge line of the rudder to the trailing edge, we talked about it being about 45% of the total chord of the vertical tail. So in this case, the chord of the vertical tail is from the leading edge of the vertical stabilizer to the trailing edge of the rudder. So multiply that by about 0.45, that would be the length from the hinge of the rudder to the trailing edge of the rudder. We also talked about the nose overhang balance. I didn't want to use a plain flap. I wanted to get a little more effectiveness out of the rudder. So instead of using a plain flap where you just have a semicircle around the hinge line, I wanted to have an elliptical nose. The chord of that nose would be the distance from the leading edge of the rudder to the hinge line. That would be 25% of the rudder chord. And I kind of picked that as a compromise between a plain flap and a flap with about a 30 or 35% chord, because I thought that had some characteristics that were getting a little bit outside of what I wanted. So 25% is a fairly good compromise. And I also decided to cut off the trailing edge by about 0.4% of the vertical tail to give me a more blunt trailing edge that'd be a little less fragile in getting damaged just from handling, but I wouldn't really have any increase in drag. Let's get on to creating a CAD drawing of our rudder. I'm trying a little experiment with this video where my screen recording software has this magnification rectangle wherever I have my mouse, and let's see if that helps a little bit in reading the tiny text that's overhearing these dialogues. And if you don't like it, let me know. If you do like it, let me know. Let me talk a little bit about the plan for the rest of this video. At some point, I'm interested in maybe doing some finite element analysis or possibly CNC machining to work on this tail and the rest of the airplane also. So I need to find some way to get the airplane dimensions out of OpenVSP, which is what we're looking at here, and into a CAD program. Inside the CAD program, at least a lot of them, you can actually do some finite element analysis. And also, with many of them, you can write out G-code files for doing CNC machining, or we could do slices for printing out templates on a piece of paper and maybe hot cutting some foam. And in addition, I need to make the specific nose shape on the rudder. I need to have a cutout for it and add nose shape to it. Those things are all either very difficult or impossible to do in OpenVSP. So we need to get our airplane out of OpenVSP and into a CAD program. Before I do that though, I need to make a modification. I learned recently that if you're using larger dimensions, in other words feet and meters, in OpenVSP and then you try to export into a CAD program, you can actually lose some of the significant digits, the lower significant digits, in that conversion. Let's say you had 1.093 feet, you could lose that last 3 digit. And that could be fairly significant on some of our dimensions, especially with these thin skins that we're using. So what I need to do is convert my feet dimensions that I've been using in OpenVSP and convert it to inches. Now you can do that one piece at a time. If you click on a component and go to the Xform tab, you can come down here and see scale factor. And for us, we need a factor of 12. So we could add in 12, hit accept, and then it would scale that component. But I would really like to do all these in one fell swoop. Do that by coming back over here and selecting everything that you want to scale. Let me expand this out and select everything I can. You can see that it popped up this group modification window. Down here then I can come in and put in my scale. Of course, if you want to move things in the X, Y, or Z location or rotate them around the X, Y, or Z axis, you can do that too. We're only interested in scale here, so I'm going to put it at 12 so we convert from feet to inches and hit accept. And as you can see, we suddenly have a much larger fuselage here. Let's zoom back out a little bit. Now, this process is not perfect. As an example, you can probably tell that our pilots are tiny little guys down in here now. Well, we have an issue with that. These humans that I'm using now have their own units. Up here we have length of unit. We need to switch all 3 of my pilots to inches. I'll do that real quick. By the way, make sure everything is expanded when you go to do your selection. If we don't expand it, let's say we just select wing geometry, it won't do everything underneath. It will only do the wing itself. It won't do anything attached to it. For example, everything I have attached, like the props and nacelles and landing gear, none of that would have been scaled if I had only just selected wing geometry here. Let's talk about exporting your airplane or parts of your airplane. The place that you do that is coming up underneath the File menu and you select Export. And there are quite a few options under here for exporting. The one that I've found the most useful is the IGES export. I had some issues early on trying to do these exports and then trying to import into CAD, and it failed over and over and over. Or if I managed to get it into the CAD, then it failed when I tried to do slices on the parts. And I finally figured out that I had been turning off split surfaces because I wanted it to come out as one big whole piece. I found out that the problem was with turning off split surfaces. I wanted my tail to come out in one whole piece and then I was going to cut it up in CAD. Well, it turns out that was causing a problem. I think the problem was up in this tip area, but I can't really confirm that. But I did find out when I decided to go ahead and do split surfaces, my problems quit and I was very happy. So leave split surfaces on, don't turn it off. Change your units to inches. Many CAD programs pay attention to inches. Some of them ignore it and just assume you want millimeters. So I explicitly go ahead and say inches since that's the units I'm using. Everything else I pretty much leave alone. I don't do the split for subsurfaces. I don't say to omit the trailing edge surfaces. I think you can work equally well whether you convert to cubic or not. And then I just go ahead and leave all these service numbering and IDs as they are just on. Now, one problem is that when you do an export, it exports everything. You can't do something like when you come over here and just say show the tail geometry and turn everything else off. And then just assume that we'll only export what's shown. It doesn't. It exports everything. So what I've been doing, let me turn this back off again. What I've been doing then is I've been cutting up my airplane. I delete all the parts that I don't want, save what I do want out to its own file, and then I do an export. So off camera, I'll go ahead and get rid of everything but my tail. Let me tell you about another thing that I do. Let me select my tail. Up here under X-form, where I've offset the tail from the origin of my airplane, I go ahead and undo that and set it back to the origin. So now the leading edge at the center is at the origin. You don't strictly need to do that. I find it a little easier to do my CAD calculations if my offsets aren't huge. And one other thing we need to do before we export. You can see down in here that we have a center section that looks a little bit like a rib. It's filled in. We need to get rid of that. We want this to be hollow here in this center section. To do that, we then come over to Plan. We come over to Tip Treatment. At the root cap type, we set it to None. And you can see it got rid of that rib here in the middle. You still see the outline of rib, but the internal part's now gone. I'm at the point now where I'm ready to do an export and then import into a CAD program. We go up to the File menu and we select Export. We then select the IGES. I want to leave Split Surfaces selected like we mentioned before. I think leaving it cubic is fine. And we're ready. Hit OK. We tell it where to save it. I've got a little FreeCAD directory where I've been saving this. And let's do video tail. And it's going to save it with a file extension of IGS. Okay, now let's switch over to a CAD program. The CAD program I'm going to use in this video is FreeCAD, and as the name suggests, it's a free CAD program. What I need to do now is import that file that I just got done exporting from OpenVSP. We come up to our File menu, we do Open, and we go down to the directory where we have our document, which is this videotail.igs. We do an Open. Now we can see the top view of our tail, and you can see that we have all these sections. Since we told it not to put it into one section, we wanted the various sections. We enabled that in OpenVSP. It's put out all these different sections, and it also has top and bottom sections. To rotate this using the navigation mode I currently have selected, I hold down Shift and then the right key, and we can rotate it around. Let's take a look and see how well it did this import for us. Let's look at the trailing edge. We got a fairly flat trailing edge here. Now, unfortunately, this really isn't ready to be worked on yet. We have to do something called selecting a workbench. What I want to do is select my video tail, come up underneath Part, select Check Geometry. Let's see if we have any problems with the geometry that we just imported. There are no errors, so that looks good. Let's close this item, select our video tail again. We need to make this a solid so that we can do some work on it. Come back underneath the Part menu, do Convert to Solid. Now you can see over here we have a solid version of our tail. Let's hide the initial version by selecting it and then hitting a space bar. So now you can see this is grayed out, which means we can't see it. We now have our solid. And just for grins, let's go ahead and do another check on this to make sure that converting it to a solid did not create a problem for us. come back under Part, do Check Geometry. Still no errors, so we're in great shape. Now that I've gotten the tail assembly successfully imported into a CAD program, I need to start thinking about how I'm going to cut my rudder out of this solid tail assembly. In order to help me figure that out, I'm going to go back to OpenVSP. Here we are back in OpenVSP. I want to add a subsurface to this rudder, and let's work on the port side rudder. The way we do that is we pick our tail section, which will pop up a wing dialog. We go to this sub tab, we pick a type, which will be control surface, and we hit add. What I'll do then is get this control surface in here into the right place. It's going to be just a little bit below where this airfoil section is and just a little bit above where this airfoil section is as far as the height goes. And of course it's going to be on the last 45% of our chord. Let's get it in the approximate right place. Let's do this endpoint first. And I'm just going to kind of eyeball it. And let's do the start also. Okay, for the moment, that's pretty good. And then we want to have this be at the what's roughly the 55% chord if you measure from the leading edge, or the aft 45%. Do that with this. And again, I'm just kind of eyeballing that. That looks pretty close. Okay, that's pretty good for a first approximation. Now, although we're close to the 45% here in this area, we're clearly not that in this area, and it looks like we're not that in this area. It's coming close to 50% here, probably close to 60% from the leading edge up here. So we probably need to make this line a little bit more vertical. Let's go take another shot at that. I kind of like that for now. In order to figure out how we're going to cut out the rudder back in the CAD program, we're going to need some coordinates. For example, we need to know where this front hinge is located. We're going to need to know where this bottom gap is and where this top gap is. So we're going to need some coordinates. So let's get started on that. What I'll do first is try to figure out the location for our hinge line up here in this area of the rudder. We'll try and make that at about that 55% chord, which would be 45% of the aft part of the chord. We can get a pretty good approximation of the location of that hinge line by coming up under the model menu and then picking the measure item. And then from there we select the probe tab and we click add. We'll get a bunch of these little circles highlighted. What we need to do is zoom in and then click on one of these little circles. Now it looks like the hinge is going to be in between these two, so I'm actually going to pick both of these. And I'm going to give some useful names. On this first one, let's call it mid hinge 4 and mid hinge aft. Down here we can find out what our coordinates are. So position in the X, Y, and Z coordinates. So we select which one we're interested in and we get our numbers. But we want to know where that is in percent of chord. In order to do that, then we need to know the position of the leading edge and the position of the trailing edge, or position of the leading edge and the distance between leading edge and trailing edge. Why don't we just pick the leading edge and trailing edge points? So let's add those in. Now we need to do some calculations. And I decided to make a little spreadsheet to make that easier. Here's a spreadsheet that I created to help me calculate some of the coordinates I'm going to need to use in the CAD program in order to do some slicing and dicing to create the rudder. These three values here are from our design. The top one is the rudder chord as a percentage of the overall vertical tail chord, and that's 45%. This second one is the percentage of the rudder chord that is going to be used for the nose overhang of the rudder. So it'll be 25% of the rudder chord. And this last one is the gap distance. This is the gap at the rudder top, the rudder bottom, and the nose gap for the rudder. Over here is the coordinate system for the whole tail. And right now I have it set up over in OpenVSP, so that's 0, 0, 0. So the center of the leading edge of the horizontal tail is at 0, 0, 0. Over in this area are coordinates that I obtained from OpenVSP using that probe method. So I have some coordinates here at the bottom edge of the vertical tail, midspan, which we just got done talking about, and at the top of the vertical tail. And let me give you a little quick peek back at where I had those probe locations. So you can hear top leading edge, there's 2 here in the middle, and there's a top trailing edge. We already talked about the mid ones. And then I have a bottom leading edge, 2 here in the middle, and a bottom trailing edge. This column is for the coordinate leading edge. This is for 1 or 2 hinge coordinates, and this is trailing edge coordinates. We have X, an alternate X, a Y, and a Z. So, for example, the bottom of the vertical tail, leading edge X, is at 20.697 inches. These white ones are the ones I'm actually interested in. The gray ones are not used in any calculations, but I do go ahead and enter those because they might help me detect that I've grabbed the wrong probe over in OpenVSP. They're just kind of used as a sanity check. We've already talked a little bit about these probe points that I did in the middle. So these are the actual values that I got from OpenVSP. Now I'm using these values to do calculations over here. So I've calculated the rudder chord in inches in this column, and then I've calculated how much percentage that is of the vertical tail chord. So subtracting this trailing edge X from leading edge X would give us the total vertical tail chord, at least here in this Z area, midway up and down the vertical tail. This is the other X, so we had 2 near the middle, so this is the fore one, here's the aft one. So I also did another calculation using the aft one. So our rudder chord percentage using these 2 X's is 51% roughly and 43%. So that kind of brackets that 45% that I was interested in, although it's a little bit closer to that aft X. So I'm pretty happy with that. I think that's close enough. Now I've also done the same thing here at the bottom. Now at the bottom we have a lot of that curvature there at the leading edge, so it's not going to be exact, but it's around 43% to 35% depending on which X we look at. Let me go back and look really quick back in OpenVSP for that. So you can see them down here. So as you can see, this hinge line here of this rudder surface we put in is pretty close to that forward X. And while we're here, let's talk about the top one again. So for the top one, we're really close to the aft X. Now I looked at these fairly closely, and it looks like we're within about 10% of this little span between this fore and aft X. So what I think I'll do is calculate the span, multiply it by 0.1 to get 10%, and then add that to this 4X, and that'll give me pretty close to the X that hinge. And then I'll do something similar up here. I'm about 10% of this little span in front of the aft X. So I'll subtract 10% of that span from this aft X, and that'll get me really close to where that hinge line is going to be. So let's go back and look at that. So what I did in this column is what I just talked about, that little 10%. So we're here on the bottom. We're just a little bit after that forward X. So I calculated the span between these 2 X's, multiplied it by 0.1, and then added it to this 37. And so I go from close to 37.6 up to 37.8. That puts us just a little bit behind that forward X. And down at the top, I did roughly the same thing. I took this span, multiplied it by 0.1, subtracted it from this aft X, and so you can see this 39.7 is just a little bit in front of this 39.8. And then just to make sure I didn't do a silly thing and make a huge mistake for a little sanity check, I calculate again what that rudder chord is going to be. So we're at 42%. And down here we're at 51.5% for the rudder chord up here at the top. So I think that's pretty good. So the hinge chord location for the X coordinate I'm going to have at the bottom is 37.79 inches from the origin. And at the top, that X coordinate for the hinge is 39.717 inches from the origin. I modified the Z coordinate for that hinge also by just a little bit. I don't want the vertical tail edge of the opening to cross any of those span sections that we made. Let me jump back to OpenVSP real quick. Let me go back to the top a little bit to talk about that gap. So here at the top of the rudder, we're going to have a little bit gap between the rudder and the vertical tail. And that's that 1/8 inch that I talked about. And this is a section line that we have in OpenVSP. When this gets exported out for our CAD import, it's going to chop our part right here along this face. I found out that some CAD programs, if you have a cut line that crosses one of these sections, especially at a very shallow angle, there are some operations in that CAD program that will not work very well across a very shallow angle across one of these cuts. What I'm going to do then is pull that top edge of that cut just a little bit below where this section line is, and then the top rudder will be 1/8 of an inch below that. And then I'm doing something very similar on the bottom, except in that case it's in the up direction instead of the down direction. And that's what I'm taking care of here. So this little calculation says take the Z coordinate at this hinge location, and remember we're here at the bottom, and then add 1/4 of an inch. So I want to move 1/4 inch up from where that probe location was in OpenVSP for the hinge location there at the bottom. And then I also do something very similar here at the top. And then this one, I'm only doing 1/10 of an inch. The problem that we have here at the bottom is that it's at an angle and it's got a little curve to it, so I add a little more margin here. At the top, it's a straight line going across there. And so I know that within 1/10 of an inch, it's just fine. So that's where the vertical tail coordinates are going to be. Let's talk about some modifications for the rudder. We have this 1/8 inch gap that I specified up here. So here at the hinge location, this Z is 1/8 of an inch above this Z for the bottom of the gap. Remember, we're at the bottom of the rudder, so we have to move up 1/8 of an inch to where the rudder is going to be. On the trailing edge, same thing. I take the trailing edge coordinate, which I've added 1/4 inch to, just like I did here at the hinge line, and then add another 1/8 of an inch for the gap, and that gives me the trailing edge to Z location. And then, as a sanity check, or possibly something I need to use in CAD, I calculate what the angle is going from this hinge location to the trailing edge location. So let's take a look at that real quick. If we come down here, so here's those probe points for the mid spot. Here's the trailing edge, and you can see it's got a little bit of curve to it, and it angles down. So that's what we're talking about here in the spreadsheet. And that's about a -1.5 degree angle from the hinge down to the trailing edge. At the top, we have something very similar, except there's no angle there. It's straight and level forward to back. So that Z location is the same. But I subtract that 1/8 of an inch for these numbers in order to get where the rudder top is going to be for the gap. So that's how we do all of our coordinates. Now let's come back over here because we have one more thing we do. For the hinge, it can be angled. Let's go back and take a quick look at that. We'll zoom out. So you can probably tell there's just a little bit of an angle here on the hinge. It's a little bit forward here at the bottom, a little bit back here at the top. So again, we'll use the X angles that we calculated in the spreadsheet and calculate what that angle is. And that's what I'm doing here. So from horizontal, it's 88.4 degrees. And if you want to think, well, how far is the angle just from vertical? It's about 1.56. And that's really kind of convenient because that's almost how much that angle is. I should say it's negative. It's not really positive. It's a negative value. But that's almost what we have for that bottom edge. That means that there at the bottom, this angle between the hinge and the bottom gap is going to be close to a 90-degree angle. Now, it's not really significant. It's just kind of nice that I'll know that when I go to work on the plug and the molds, if I can take a quick look at that, and if I see roughly a 90-degree angle down here, then it's at least a simple sanity check to see if I have made a mistake or not. If it's close to a 90, I've probably done the right thing. Well, the next thing to do is to use all these values I have calculated in here to start slicing and dicing what we imported into OpenCAD and start cutting the rudder out of that tail solid that we made. It's time to do some slicing and dicing on this tail so I can cut a rudder out of it. The way I'm going to handle this, since this video is getting kind of long, we need to save some time. I'm going to do a brief summary of what I plan to do, and then I'll just, in fast forward motion, go ahead and perform those operations. So the first operation I'm going to do is slice these two vertical tails down here at the bottom of where the gap will be for the rudder. So let's get started on that. The next thing I'm going to do is slice off the tip here. And I'm going to slice it just a little bit below this horizontal line, and the slice is going to be horizontal. It's not going to be angled like this bottom one was. This one should be pretty fast and easy. I'm going to do one more slice. This time I'm going to cut right down through the hinge line. And that'll give us the aft part of our rudder from the hinge line to the trailing edge. I have the rudder oriented now, so we're looking at the top, looking down on it. So this is the hinge line. Here's the top, here's the trailing edge. What we need to do now is make the nose. And as we said in our design video, we want to make the nose elliptical. So somehow we have to attach an elliptical nose to this front. I want the very leading edge of the nose to be straight, and I want the elliptical to follow this surface here and this surface here. Now you can see that these surfaces are curved, so we actually have to do a loft instead of an extrusion. What I need to do is make a couple of semi-ellipticals here. I'll draw a straight line along the leading edge where those two semi-ellipticals join, and then I will have to do a loft if I was in something like SolidWorks. Unfortunately, I can't do that here in FreeCAD. It has a problem following more than one contour when doing a loft. So what I'm going to have to do instead is something called surfaces, and we'll get to that shortly. But first, let's put our semi-ellipticals in here. Now we've created a sketch of at least half of the semi-ellipse here on the nose. So here's the very leading edge. This is the semi-ellipse coming back to the hinge line of the rudder. I used a calculation to make the length of the nose be 25% of the rudder. And you can see that when I pop this up and come over to the formula. So I made a constant over here, which is the length of the rudder, which I called CR. Multiply that by 0.25, and so it goes ahead and does the calculation for me. What I need to do now is make the other half of this semi-ellipse and then go on the back side, the bottom side of the rudder, and do the same thing again. I now have a nose profile here at the top of the rudder. It's in two parts, where this little dot here is the leading edge, and I have another elliptical nose profile here at the bottom of the rudder. The next thing to do is connect up a straight line between this leading edge dot and this leading edge dot. Well, now I have all of the profiles and edges I need to make a curved surface for the nose. So next thing I'll do is I'll make a surface using 4 edges. So the leading edge, a hinge edge, and then half of these ellipses. Now we have half of our ellipse, and let's take a look at it. That looks pretty good. I do have a little bit of a problem. There's an error that FreeCAD made when it did a slice for this hinge face, and you can see it kind of sticking up here. So this face is actually sticking past the hinge a little bit, and then I think it folds right back to this edge. At least that's what it looks like. Let me do a little rotation here and you can see what it looks like from the end. Let me zoom in on it here so you can see it sticking up there just a little bit. So I think it's very thin and just sticking up and then coming back down to the edge. That presents a little bit of a problem because when I try to make a surface like we just did over here using this edge, it crashes OpenCAM. So I'm not going to bother finishing out this little edge, but I will make a face on this end and a face on this end on the ellipse, and so we can kind of start to see what it'll look like put all together. So there it is. We have a nice surface here, we have an elliptical nose, and we have the rudder from the trailing edge up to the hinge line. And let's take a look at the other end. So there's what it looks like from the bottom end. Now if I wasn't having a problem with this other surface, what we could do is put all of these surfaces together and make it a solid. And we'd have these two solids together. And then we could start slicing it up if we want to do some hot cutting on some styrofoam. Or if we had a CNC machine, we could CNC using this solid. By the way, I have done all of this with the SolidWorks CAD program and had absolutely no problems at all. I was able to make a nice solid out of it. I am having a little trouble with OpenCAD, but I don't think it's insurmountable problems. I was pretty dissatisfied with not being able to get both halves of the nose of that rudder to get some nice surfaces, so I went to the starboard rudder and tried again, and by golly, it worked. I got a pretty decent rudder set up now. Let me do a little rotating around. So here's the top looking at it. So here's the nose part. Here's the regular rudder part. And let's take a look at the bottom. You can see the curve here on the trailing edge where it gets narrower at the top and wider at the bottom. And let's take a look at the trailing edge. So you can see how it's flat here on the back. Come down to the bottom here. Now it's kind of hard to see the elliptical shape of the nose on this end, but if we flip it over, it's a little easier to see the elliptical shape on this end. And that's just because on the bottom side, it gets thicker faster. That means the 25% nose length has a thicker area here, so it's less of a semicircle, but you can still see it is. Now, not only did I go ahead and get a decent rudder, I decided to go ahead and work on the vertical tail too, so you can see the two together. So let me bring that up. So now you can see what it looks like with the vertical tail cut out. So this part here, where the nose of the rudder comes up to the vertical tail, this is a semicircle. So it's got the radius that is the same as the length of the nose plus 1/8 of an inch. So there's 1/8 of an inch gap right here between the nose and the vertical tail. And that gap will remain that distance as the tail deflects. So if we had the nose all the way up here to this edge, it's still an 1/8 of an inch gap. And just for grins, let's go ahead and switch around and look at the top. So you can see what it looks like there. You can look at it looking down it. And to kind of help you see what it looks like when we add the horizontal tail in, let me do that. And by golly, let's just go ahead and add in the tip also. So that's what it looks like all together. And let's rotate this around so you can see the gap. Tell you what, let's rotate it around this way. So if I bring this down far enough, there we go. So you can see here, there's an 1/8 of an inch gap between the rudder and the horizontal tail. And if we go up to the top, again up here we have the 1/8 of an inch gap. So I was eventually able to get this rudder created using FreeCAD. It's a little bit of trouble, and as I mentioned before, when I did it in SolidWorks, it was smooth and easy to do. FreeCAD is just a little more difficult to use. It has some problems. It's still not even reached version 1.0. It's at 0.18.4. And it's awfully close to being usable. And it's possible you can make it usable. I haven't yet gotten to the point of trying to slice up the rudder so that I can export it into drawing files that I can then print out and use as templates to cut out foam. I don't know if that'll work or not, but at least as far as drawing it and looking at it, I have been able to get that to work. Now, there are also some plugins for FreeCAD that I haven't played with yet, but supposedly I can run some aerodynamic simulations on parts that have been made in FreeCAD. I haven't really looked into it yet. I just know that someone has created some plugins to do that. If I can get that to work, that might be pretty useful too. Well, as I said before, I'm sorry about how long it took this to get put into a video, but I was fighting FreeCAD and a little bit of OpenVSP trying to get this to work. For my patrons that are on the designer tier, I'm thinking of making a tutorial once I've gotten just a little bit more familiar with FreeCAD on how you can avoid some of the pitfalls that I spent a whole lot of time on. So if you want a FreeCAD, hopefully you can learn from my mistakes and you can get things working much faster. Well, thanks for watching, and we got more videos on the way.